The following is a production of Woods Hole Oceanographic Institution.
I don't think there's anybody that doesn't look out over the ocean and, at least for a second, feel that sense of awe and that sense of mystery, wondering what is beneath the waves.
We're trying to figure out what is the big picture from just a very few pieces of the puzzle.
If we look at the oceans, they are the least understood area on the planet.
All the patterns we see in our ocean are linked to different systems. It's chemically linked, biologically linked, geologically linked.
A lot of the questions that we ask aren't departmental. It's very interdisciplinary.
And so having these people here all under one roof creates an important collaborative atmosphere between scientists working in these different disciplines.
There's no better place that I know of to have that critical mass of intellect than the Woods Hole Oceanographic Institution.
I consider myself first and foremost an oceanographer, and my lab's particular expertise is looking at molecules and microorganisms. So in a single gallon of seawater, there are more microbes than there are people on Earth. Even though they may be tiny, we use them as tools to tell us about the bigger picture.
I'm a physical oceanographer, and I study ocean currents. The oceans are a critical part of the Earth's climate system. My research is to study where that water goes in the global ocean and how it gets there and how quickly.
I'm an evolutionary biologist who cares about how life evolved in the deep sea. So I have to look at how the complex processes of geologic history have shaped the deep ocean, but also look at how the chemistry and the circulation patterns of the deep ocean influence how species are distributed. I could go on about all the great adaptations they have, and that's why it's so fun as a biologist to be able to do deep sea oceanography, do deep sea work with new discoveries made every time we go out.
I am a PhD candidate at the MIT Woods Hole Oceanographic Joint Program. I'm trying to build a better scientific understanding of how human-made noise may be affecting baleen whales. When we talk about pollution in the oceans, we think about oil spills and toxic chemicals and such, but noise pollution is also a form of pollution that you can't see.
I'm an associate scientist here in the Department of Applied Ocean Physics and Engineering. I wear two hats. I have one hat which is building robots, and then the other hat I have is working on imaging systems. And actually it goes a little bit hand in hand. We've really led the field in terms of large area imaging, everything from imaging the Titanic to imaging coral reefs to imaging the underside of sea ice, building real quantitative maps of the seafloor.
We're trying to observe the ocean, which is a very difficult place to work. The weather can be bad. The ocean is dark and deep and hard to penetrate with communications equipment to find out what's going on.
At Woods Hole, we're fortunate to have the research vessel Nor and the research vessel Atlantis, which are among the two largest research vessels that we have in the United States. These are important national resources for oceanographic research.
Alvin is a manned submersible which was originally built in 1964. It is one of the most successful pieces of underwater instrumentation. It has a host of discoveries to its name.
I've been very fortunate to have over 50 dives in Alvin over the last 20 years, and it's made my research career start. It's been fantastic. It gives you something that no other vehicle really gives you, and that's your eye on the seafloor, and nothing can surpass that in my mind. We have engineers here that are top-notch. So when I have an idea about going to the deep ocean and what it's going to need, I go to them and I can see them. I mean, interact on a daily basis. We have a vehicle here that can go to full ocean depth. That's 7 miles down on just a hair fiber, a microfiber. It's revolutionizing what we're able to do.
We're now at the stage where we are really trying to push the limits of using our robots. What we'd like is to be able to collect data over long periods of time.
We live on an ocean planet. The future of the sea and the future of humankind are intertwined. And at Woods Hole Oceanographic Institution, we are in a unique position to begin to be able to look at how humans and the ocean are intertwined and to think about the role the ocean is going to play in the future of our species.
The public needs to know much more about how the Earth works, so that as time goes by and we need to make important decisions about climate change and how we're going to adapt to it or try to mitigate it, that we make well-informed decisions.
Ultimately, I hope that my research will help in the creation of science-based conservation and mitigation policies.
There are many things that are unique about this institution, and you could say the intellectual freedom, you could say the quality and the interaction we have with our students and postdocs, our education programs. You could say it's our ships, you could say it's our engineers, you could say it's the tremendous intellect of people that are here, and if you said any of those, you'd be right. I think it's a complete package.
To learn more about Woods Hole Oceanographic Institution, visit us on the web at www.whoi.edu.